Hi, in this video I will explain FISTs, which is a tool to perform security testing in software-defined networks. The objective is to perform testing of the network, which may have many sources of vulnerabilities, also very frequently reconfigured, and certain assets are deployed close to end users, which are physically reachable. SDN may contain components that are sourced from different vendors, such as SD-WAN from Juniper, routers from Cisco, or 5G services from Azure PMAC, so on and so forth. These components are configured independently. Different SDN vendors may have different configuration file formats, so it's not feasible to test with one single tool. To address this problem, we propose a black box testing approach. Our idea is to test software-defined network hosts in the field after each reconfiguration. Here we have an example where switches are in gray and hosts are in blue. We have a SMB server deployed on IP A2, which is listening on port 445. Then imagine we have an end user request to SMB server, which reached to SMB server via switch SA. In the flow table of switch S0, we have a high priority rule that forwards all the traffic from SMB server to SB. In an update, the SMB server is moved to another switch called ST to optimize resources, but a high priority rule stayed at switch S0, due to which all the traffic for SMB server is routed to the wrong destination, which is a confidentiality problem. For FIST approach, imagine we have the same initial configuration like before. The traffic generation component sends packets over the network for information gathering, and responses are monitored. After the update in configuration, we perform same type of information gathering on the updated network. The network data gathered in both scan is then processed by host matching and comparison module, which identifies that port 445 on host 3 have changed from open to filtered. It is also responsible to generate a detailed network state change report to capture such changes for all the hosts in the network. Hosts that are new or are removed during the update in configuration are also accounted for by host matching and comparison module. Then we execute vulnerability prioritization that relies on unsupervised learning algorithm to prioritize the inspection of hosts based on vulnerability score. The prioritized list of hosts are manually inspected by the engineer. This may help to identify anomalies in the start during the inspection. As for the tutorial, here we have two virtual machines for Open Daylight Controller and the second VM for topologies. I will execute Open Daylight Controller and OpenFlow Manager on the controller VM on the left. Here we can see that our Open Daylight Controller is now up and running, and our virtual machine IP is .106. We rely on Mininet to generate virtual topologies. In the Mininet VM, I will execute initial configuration, then deploy SMB server on host A2, and then take the network scan using Nmap. I will use Xterm to SSH into A2 for SMB server deployment. Now the SMB server is listening on port 445. Now I will initialize the network scan from another host. The results from the scan are saved in an XML file. We do the same type of scan for the updated configuration. For the FIS tool execution, both initial and updated network configurations are placed in the Nmap output directory. and then we initiate the FIST pipeline. All the FIST modules are integrated in the pipeline and are fully automated. Currently, we have deployed three algorithms for host prioritization that are KNN with distance 15, isolation forest, and OCSVM. The output of the FIST tool are saved in the result folder. We receive three CSVs, one for each algorithm. If we take a look at the results, we can see that host 1 with IP.116 was correctly matched by the host matching and comparison module with the correct IP in the updated configuration, which is mentioned by IP2. If we take a look at the last column, which is the anomaly score that is being generated by KNN, the higher the anomaly score, the most vulnerable host could be. The engineer is responsible to monitor the host from top to bottom. The intuition here is that all the vulnerable hosts are scored more anomalous and therefore will be identified early on during the testing of the system.